Good morning, kids. In today's class, we are going to discuss about the horizontal projectile. Horizontal projectile motion. A very simple topic and very important also. So let's assume the basic condition. So let me have the tower. Now, what is a tower? Some cliff, tower, anything you can call it. So from here, we'll project a particle. So let this be a particle. I'm going to project a particle with the speed u, with the horizontal speed. So here what I'll be doing, I'll throw this particular stone ball horizontally. Then how the particle will move? What are the forces they'll be acting? The weight mg will act. Due to mg, then it will have acceleration along y-axis. So what is this acceleration? mg by m will be g, and how it will be directed downward. So therefore, we just show that because of the gravity and the velocity, the particle is going to deviate. So it's going to deviate and it will come and strike the surface somewhere at a point. Here the ball will come and strike it. It will come and strike the ground at some distance. Now, so let it have the velocity. At t equals 0, it was projected. At any instant of time t, let Vx be the horizontal velocity, let Vy be the vertical velocity, and the velocity of ball, let it be V. Let me choose this as origin. So then this distance will be x and this will be y, where this will be the position vector. What is r bar? R bar will be the position vector. We'll assume all the quantities which will be moving. What is this? This is the path of the ball. So how the path of the ball is going to move? Instead of moving horizontally, it will move in a curved path, parabolic path. Already we have discussed. Okay, once again we'll revise it. Now this will be, we'll write equation now. Along x-axis, x is equal to ux t plus x t square by 2. There is no horizontal acceleration. And what is the vertical acceleration? Equal to g. And what is the initial velocity along x-axis u, and initial velocity along y-axis is 0. Then how the particle? Now equation, this will be u t plus 0 or x equal to ut along x-axis. If you look at the along x-axis, there is no acceleration. So ax will be 0. So we'll end up this equation. Along y-axis, y equal to uy t plus ay t square by 2. What is the initial velocity along y-axis? 0. It will be 0. Right, 0 plus this will be g. What is the acceleration along y-axis? It is equal to g, no? So therefore this will be g t square by 2. Now what is y is equal to g t square by 2. Let's substitute. X is equal to y equal to g by 2. This will be x bar so this is the equation for parabola, parabolic equation. Look at this quantity. How do this you look at only this. It is like similar to equation of y equal to x square. So what should be the path now? This should be a parabolic path. So what is the path of the ball now? We'll discover a parabolic path. So it's going to move in a curved path, a parabolic path, and will come and strike the ground with a certain speed. Now after this, I'm interested in to find out this range on the ground, horizontal range we'll call it. Then it will take some time to reach the ground. This is called as a time of flight. First, we'll calculate the time of flight. So what is the height it will descend? It will descend in a height h. So therefore, this should be equal to h is equal to uy t plus ay t square by 2. What is uy? Uy is equal to 0. Initial velocity along y-axis, it is 0. Then acceleration along y-axis, this should be equal to g t square by 2. So what is the time of flight? Time of flight is given by 2h by g. This quantity is called as a time of flight. Then what about the horizontal range? This horizontal range we have to calculate. So the horizontal range will be equal to r equal to ux t plus ax t square by 2. What is the initial velocity along x-axis? It was u t. What is the horizontal acceleration along x-axis? 0. There's no horizontal acceleration along x-axis. We'll indicate this clearly. Okay. Acceleration due to gravity. Now come for this one. This should be equal to ax. This should be g 0 t square by 2. So what is the range? Range will be now r equal to ut. So this is called like a horizontal range. Then it will come and strike the ground with some speed and let this angle be theta or phi. Call this Vx dash. Some other symbols will give. Now, how to calculate this horizontal velocity? The horizontal velocity everywhere will remain constant. This is something very important one, which I should indicate. The horizontal velocity so what is Vx equal to Vx dash equal to Vx dash should be equal to Ux, which is equal to E. The horizontal component of velocity of the particle will not change. It will remain constant. Any reason for that? There's no acceleration along x-axis. Vertical component of the velocity should increase with the time. The reason because of gravity, because of there's acceleration along y-axis. Okay, no. So we got what about Vy? Vy is equal to Uy plus Ay into t. This is 0 gt. Then what is the speed? Equal to Vx square plus Vy square. So this should be equal to U square plus gt whole square. So can we find out now this angle phi? This angle should be equal to tan phi should be equal to Vy by Vx. So based on that, so what is the tan phi? Yeah. Look at this triangle. I think I'll help you with this. So what is the tan phi? Vy will be gt and d. Like this. Like this, we'll get the angle made by the velocity vector when it is striking the ground. The angle made by the velocity vector just before the ball striking the ground. Okay, there's one background what student needed, a horizontal projectile, very, very important. So of all thing is, you should not forget this one. The horizontal component of velocity as that ball falls will remain constant. The vertical component of velocity will keep on increase. So like still some confusion. We'll have one small diagram. If you look at this is our cliff. This is a ball which will be projecting. Then how it will move? It will move in a parabolic path, a curved path. It will come and strike the ground. The horizontal component of velocity will not change. the vertical component of velocity will keep on increase. v1y, v2y, v3y. So here we can write like this: v4, v3 greater than, but horizontal component of velocity remains constant. Any reason for that? Because of this acceleration. Because of acceleration along y-axis, the vertical component will keep on increase, whereas there is no acceleration along x-axis. Hence, what we can write here. Hence, there's no acceleration along x-axis. So horizontal velocity will remain constant. There's acceleration along y-axis. So vertical component will keep on increase. This is a basic thing. And now what is this? This can be a ball, stone, any object. Usually we'll prefer a small body here so that you can analyze the motion clearly. And what is this path? This path should be a parabolic. Okay, kids. So tomorrow we'll continue with one more condition. In the horizontal projectile, we'll bring different cases. Okay, thank you all of you.